Good afternoon, everybody. I'm glad to see so many of you here today. Move along in, move along. So we're gonna talk this afternoon about some work we're doing in the space of enabling SaaS application development on the SQL Database platform. These applications look like they're absolutely set to explode. I think there are predictions now that from something like 40% of the cloud application portfolio in something like 2014, they're expected to grow to something like 70% by 2020. And if we're building SaaS applications, many of these are data-intensive, data-rich applications built on relational databases. And what we've been learning from many of our customers is patterns and best practices for building these. And I'm going to try and share some of those with you today. It's a particular company that we've worked with, MYOB. I'll be talking about them in a bit. And they're sort of emblematic of what we're seeing being done. For sure, the very largest installations on our platform, on SQL Database, are in all cases now SaaS applications. It's pretty exciting for us. So my name is Bill Gibson. I'm a program manager in the SQL Database organization, particularly looking at the problem, if you will, or the opportunity that is represented by SaaS applications in the SaaS space. And indeed, it's a huge opportunity for you as ISVs and obviously for us in terms of delivering a platform to support you. So what I want to try and do today, let me see. There's a clicker here somewhere. So the objectives and a takeaway that I want you to kind of get one thing from this session. So my goal today is to help you, to equip you with some insights and understandings about alternative data models that you can use for building SaaS applications. So different ways you can organize the databases underneath a SaaS application. And I'm talking about typically today, most of my focus is going to be on multi-tenant applications. So applications where you expect to have many customer sign up and use our application. So that's the kind of class of application that I'm talking about. So I'm going to provide you with some pros and cons of those models, and then we'll go on and look at these patterns and sort of practice those in the context of a sample application. I'll talk more about that in a moment. And you'll get that sample application. So we've made a sample application available. And I'll both be showing you the application and using that as a sort of context, but also showing you how to get the application and how to install it yourself. And if there's one takeaway I'd like you to take with you, it would be this, that the SQL Database platform particularly, but the PaaS platform, a managed platform then, with a set of patterns that sort of enable it for working with SaaS applications at scale. So we're talking about building applications with thousands of databases, tens of thousands of databases, perhaps hundreds of thousands of databases. So certainly hundreds of thousands, perhaps millions even of tenants in your application. So that's the kind of thing we're talking about. This platform then is, with these patterns, is particularly suited to doing this. And we've spent a lot of time enabling that in the technologies we've been building. So I want you to sort of get that sense from what I'm doing and what I'm going to show you today. We also want your feedback. So it's a key thing about today is to show you the work we're doing, but actually ask you to kind of come back to us, to try out that sample, come back to us with feedback on it. Okay, so in terms of getting through this, I'm going to show you first of all that application. So we'll have a quick look at the sample. Then I'm going to sort of just survey quickly some concerns that we hear from ISVs who are building applications. So, what is it that worries them when it comes to what are the criteria they're looking for as they judge the data management solution? Then we'll look at these data models, and we'll try and use those criteria then to assess the data models. We'll talk through a set of those, and then we'll shift into some of these patterns and the samples, and we'll use, and I'll show you some of the management scripts. A lot of the samples are actually geared around management. How do I manage those thousands of databases? How do I optimize and maintain them, for example? Okay, so let's take first of all a look at the app. So it's a so this is it goes by the name of Wingtip. Wingtip. It's a SaaS app. It's a multi-tenant app, the class we've talked about, and it's targeted at small venues that are hosting events and want tickets for those events. So it's kind of a simple scenario, and I don't want you to get too sort of fixated on the app. The app is really just a vehicle to help us tell this story about the data platform that we're using underneath it. So here's the app. You can see some images of it there, and I'm just going to show you a couple of things about it. So it's a simple, straightforward web app. I can browse. So I'm here connected to a particular tenant. It's the Contoso Concert Hall, one of Microsoft's favorite names, of course. And they are hosting some events. We can see a range of events. And I could go off and I could buy tickets. I would need to sign in to purchase these tickets. And I can go in and I can give credit card information. You won't actually do that in the sample, of course. And you can make use of this to purchase tickets. And it's not just doing this for Contoso, but we've got other tenants here. Here's Fabricam, and here's the Dogwood Dojo. Here's apparently you can buy tickets for judo tournaments with this as well. And really the point here is it's a multi-tenant. Each tenant gets a customized experience. Each tenant has got their own data. So that customer data, event data, ticket data is all precious to those venues. They don't want that data incorrectly provided to other tenants or exposed in any other way. So it's a precious resource for them. So that's the app. Let's come back to the we'll come back to the app several times to explore it a little more and explore some of the lessons, and we'll learn how it's built in a moment. Okay, so let me move on here. So let's talk about how we might organize the data. How was this data stored behind that app? That's the kind of interesting question. But before we do that, let's think again about these concerns. What is it that worries me when I'm thinking about designing the data platform for a SaaS app? So one of the things we hear from lots of people, not everybody by any means, is people who are building very high-value apps with high-value assets in them. Actually, per tenant database cost isn't an issue. As somebody who's got just a few tens or hundreds of tenants, then that's not going to be their major concern. But somebody who's building an app that's got thousands of tenants, perhaps targeting a low price point in the market with their own application, is looking for a low price point from the database. So that's an issue. So what's the cost to serve a single database or a single tenant? So then the notion of scale, the issue of scale, often goes hand in hand, as I've just implied there. No one wants to start down a path that's going to limit them ultimately. And everybody building a SaaS app has got visions typically of a very large deployment of that application in their future. And so they don't want to invest in something that's not going to take them to that future. And there's issues around isolation. And this is perhaps cost and isolation, perhaps the two biggest ones that we hear most about. And here, from an isolation standpoint, there are many factors, actually. Security, performance, lifetime management. If I wanted to recover a single tenant, how would I go about doing that? If that tenant is an instance in a database with 100,000 tenants, how easy is it to recover one tenant's data? I know some vendors don't offer that option because it's too complicated. Interesting situation there. And then issues around business continuity and disaster recovery, so concerns about moving data into the cloud and the possibility of an outage. How would I recover? How would I maintain my business in the face of that? And then customization. And we don't hear this from everybody, but for some ISVs, this is particularly important, the issue of customizing, being able to say, this tenant has different data than this other tenant here. Or we have a class of tenants and another class of tenants. Or, for example, applications which are modular in themselves. So different modules of the application need different storage, and you want to be able to offer that in some incremental way. So these are what we hear as kind of issues as we look forward. So in terms of that application then, how might I then store the data for that application? And how does these options address those concerns that we were going through just now? So there are three main models. One of them is the simple multi-tenant model. And in many ways, that was the de facto way of doing this in the past. And many of our customers thinking of moving to Azure actually have current SaaS applications, maybe with in a data center that's outsourced somewhere, running on some big database. I know we have one accounting customer who's struggling with a 6 terabyte database containing the data of 120,000 accounting tenants and wanting to do something very different. So that's been typically where the world kind of has come from, and it's been the easy solution in some ways, because it's the one you can all think of sort of off the bat. And of course, as you scale this, you simply build the database up in size. So that's one option. Another one is a kind of similar version of this, but it's a sharded option. You take that database, and now in the spirit of the cloud, you say, well, I'm just going to be able to scale out more databases. So let me use this storage for multiple tenants, but not try and get all of them in there, but just grow this out over time, scaling it out horizontally to support more tenants. And then the model which tended to be ignored by many people before the sort of cloud and the sort of advent of managed services in the cloud was this one, having a database per tenant. And the kind of obvious reason is the kind of complexity, the management complexity that would come with having potentially thousands or hundreds of thousands of databases. What I want to sort of show you is in part today, but is that one of the things we've accomplished is making that a practical solution in the cloud. We have a tenant, a customer, MYOB, which I've mentioned, who are running over 100,000 databases, and I'll talk more about that in a moment. So those are what we see as a sort of three main patterns, and there are various ways that you could shard, by the way, but the pattern we see most often is sharding through some tenant ID, so some tenant key. But there are other strategies. People have used sharding by schema and actually putting and aggregating data by or separating data for different tenants in different schemas. There is another model, though, which I want to bring up, which is an interesting hybrid of these, which takes the sharded model and says, well, so that's interesting. I can now separate tenants into these groups of databases. That has some great economies of scale. But what if I wanted to also pull out individual tenants from that set and actually allow them to be deployed in single databases? Could that be done? And this is a model that we find very interesting at the moment. We've done work to make sure we can do this, whereby you can literally move a tenant out of a shared multi-tenant database into a database of their own. And then effectively you can manage them at that point as if they are in a single tenant strategy. So if we look at these and consider the sort of pros and cons of this. So look first at the multi-tenant ones. So these are particularly good for supporting extreme scale. There's no question that you're going to be, you're not going to be thinking about a million plus or 10 million databases. It's extremely unlikely that's a good idea. Whereas you could easily have a tenant population of that scale inside a database or inside sharded databases. So this typically gets you the lowest per tenant cost as well, because you're going to take a database and you're just going to jam things in there into that database. And it's extremely sort of cost optimized, but for that class of solution, typically small amounts of data. So obviously you've not got a great isolation story here intrinsically. You've got all these eggs in one basket effectively, or a small number of baskets. So there's a greater sort of risk, if you will, through the potential issues there. You've certainly got things like performance isolation may be an issue for you. So we talk about a noisy neighbor syndrome, where the performance, the sort of workload of one tenant might impact the response time of other tenants. And so you have to be concerned about that if you put large numbers of tenants in a single store. There's also some complexity. I talked about the lifetime management. There's complexity there in terms of, I give you the example of recovering a single tenant's data. So if you have a large number of tenants in a database, you have to work hard to, you have to work your way through. It'll be an application problem to manage recovering a single tenant's data. So if we take a look at the multi-tenant, single tenant, but multiple database. We often call this a database per tenant model. So this gives us the strongest tenant isolation. So we can now give specific databases performance objectives. We can resource them separately. We've clearly got the boundary, the intrinsic boundary of a database from a security standpoint. If my app makes a connection to this database, it's not connected to any at that moment. And so that gives you a strong isolation at that point. It tends to have higher per tenant resource costs. That's the sort of corollary of the multi-tenant having the lowest costs. I'll talk about that in a moment. There's also a sense in which it's more complex to manage. We've got more moving parts now. We've got more databases, and again, I'll talk to that. And as I've sort of implied, it's overkill for either very small tenant scenarios, where you've just got a few, 50K of data or something per tenant. It's putting an entire database up for that might be considered overkill. And it's not practical at extreme scale. We don't yet have, and I don't think I would recommend you to have multi-million installations of single databases, even on Azure at the moment. So we'd love to take you towards that point, but if you're doing that, that's probably not the best solution. And of course, the hybrid one sits in the middle here. And the opportunity here is that from a sort of pro here is you get to choose the isolation level that you wish to give a particular tenant. So you can imagine a scenario in which if you have a free or trial plan for an application, you have them sitting, people who are sort of kicking the tires of your app, they're sitting in a multi-tenant database, and if someone elects to purchase and to use your app as a paying customer, or perhaps takes a premium plan, then you would give them a database and give them performance guarantees and an SLA that perhaps matches that's appropriate now to the fact that they're a paying customer. Obviously, you're incurring some of the complexity now of having a sharding model. You have to step up to that. So it's not, you're paying some price. But it's an interesting model, and I'll show you that in a moment. Because for one application with absolutely no change to the application, you can have both of these, the benefits of multi-tenant and single tenant available to your app. So that's pretty interesting. Now, I mentioned the higher per tenant costs of the single tenant or the database per tenant model. Well, one of the interesting things about Elastic Pool, and let me just clarify that. So if you, in fact, let me do it on the next slide. So those are on the left there, those are databases that are one per tenant. And the little graph lines, spark lines inside there, intended to represent the workload over that database. So one of the characteristics of SaaS applications is you as an ISV typically cannot predict what's going to happen in terms of the workload on the databases. You have no idea. I mean, take MYOB and their accounting application. They have no idea who's going to log on any one day of the week and use their app. They don't know whether they'll log on in the morning or in the evening or if at all on any one day. And in fact, most of their customers don't log on most days of the week. And that's a very common pattern that we see for applications, particularly smaller scale applications targeting smaller kind of organizations. Not always the case, but if that is the case, and it's remarkable how much workload what I'm about to show you will benefit. The point is it's individually unpredictable and expensive if you are going to scale each of those databases to handle the peaks. So when those guys do log on, and you've no idea when they're going to log in, if you still need to have a certain number of resource capacity available to give them the response time they want, then having every database sitting there waiting with those resources allocated is expensive. So there's a solution. It's called the Elastic Pool. And the Elastic Pool basically gives a bucket of resources that can be shared by databases. So now instead of the databases individually consuming resources, they're doing it in the aggregate from the resources in the pool. And now you see quite different trends. They're typically collectively stable. So this might be an hourly average load across that. You now see things like patterns like a daily pattern, and I'll show you an example of that in just a moment. You might see weekly patterns. You might see seasonal and annual patterns. You see things like the tax season is a blip for MYOB, which is in June in Australia. So they, around that time, will think about scaling up their pools to provide more capacity in the aggregate for customers who need that. So let's go back to our sample and ask ourselves the question, well, how did we implement that? So let's go back to the sample here. And so the answer is we did two of them. We built two versions of this. So this version here we're looking at is actually built on a database per tenant version. This is a database per tenant version. So each of these has a database. And I was going to ask you if you could tell the difference, but here's what's going on. There's down here in the bottom corner, let me see if I can pull this out here. I hope you can see this. There's some sort of debug class information. You'd never expose this in a real world application, but this tells you that the database that's actually connected. So each of these, the app here, as it shows this tenant's data, is also reporting where it's finding that data. And it's found that data in a database, the Dogwood Dojo database here in this example. And we go to Fabricam, we scroll down and see if I can do the same thing, if I'm coordinating enough. And this is from the database, the Fabricam Jazz Club database. So I said we built two versions of this. So this sample is available now. This is the one we've had out since May. We're now building right now a hybrid multi-tenant version, and we should have it out within a month of now. So I'm hoping by the end of October we'll have this available. So let's take a look at that version. And the first thing to know is it's the same. It's exactly the same app, and that's really the point. Of course. So and let's bring up, where are they? Where are you? I think I just closed one. Doesn't matter. We have a hub here, and I can reopen Fabricam. Yeah, there we go. It's the same one. But here the difference is Fabricam is coming from a multi-tenant database. Whoa. That was not what I intended to do. Let's try that again. So this time it's coming from a database called tenants1. And all of the tenants that we see in the first example are also coming from that database. But what I've also done is I've installed a couple of new tenants. So there's a set of tenants that are in common with the first application. I've got a couple of new tenants. Here's one here, Redwood Rock. And if we look down here, we can see that this guy is coming from a database that's unique, that's for this database. And if I were to look at this other one here, Salix Salsa, you can see that's the same thing here. It's coming from a database called Salix Salsa. In other words, we've mixed the two modes side by side. And let me show you that in the portal. So let's go back here. This is the single tenant one. And I'm jumping ahead here. Go back to the server. And what I want to show you here is that there's a slew of databases. So here are the databases. You can have up to 5,000 on a server. You can have up to 500 in a pool. And so here we've got databases deployed in that manner. If I now go to the this guy here, again jumping ahead, we can say the same set of databases, same set of tenants supported, plus two extra that I added there. All the core set of tenants are in the tenants1 database, a multi-tenant database, and we've got two other databases. So we've got this mix of databases and with different roles, playing the role of being. Now you can pick any balance you want. You can choose to put five customers tenants in a database. But these two kind of points of many and one are the significant ones because now in the many I can manage them in the aggregate through managing performance of the database for a set of tenants, versus in the one I can manage them independently, individually. Okay. So let's now go back to the deck. What I want to do now is just, so we've seen now, we've got these two approaches that are particularly popular and particularly interesting. Let's go talk about MYOB. MYOB, because what we've done is we've taken these two approaches and we've built out a set of patterns on them. Patterns are based on experiences that we've acquired over the years with MYOB and many other companies we're working with. These guys are interesting. I've worked with them very closely for a long time. I've talked about them, introduced them already, an Australian accounting firm. They took a desktop client-server app and migrated it to the cloud. And that's an interesting move in itself. It'll be something that's common for many ISVs moving apps to the cloud, is they have an app already, and it already talks to a database. And so they were able to make use of the fact that their app expected to connect to a database that only contained one tenant's data. And so they were able to leverage that, a large amount of the code as they were building their cloud version of their applications. It assisted them in migrating that app to the cloud. So that was a cool thing. They started off some years ago. Some of you may be familiar with our older kind of offering, so-called web and business databases. They started off on web databases. Those databases were sold by size, not by performance, not by the resource capacity. When we moved to selling and pricing our database service by resource capacity, they then at that point shifted to using elastic pools and kept that single database underlying model, single database per tenant. They have some interesting complexities in their model. They actually have multiple single databases per tenant, in as much as they allow the tenant to go offline, take the database offline, and then when they come back online, they'll actually they'll synchronize a copy of the database, creating them a new database. So they'll actually cycle through databases in the cloud based on the number of times a client has taken their data offline and online. So some of their 150,000 databases represent additional databases that are being created as part of that cycling process. So that's an interesting part of their model. They did a proof of concept for a multi-tenant database, and they came to us and said, held up that against our Elastic Pool offering and said, well, which one should we go with? And we quite like our proof of concept, our multi-tenant offering. And at the end of the day, what really happened there was, while they thought they could run it for about the same price or less than they could run databases in Elastic Pools, actually they didn't want to become a database platform vendor themselves. They didn't want to take on the work of managing and building tools to manage their tenants inside that multi-tenant environment. What we were able to convince them of is that we were building tools that were database focused and would actually build out a whole bunch of management scenarios. Pools were just an example. We have other tools I'll show you in a moment that are. So basically, they took the decision that their total cost of ownership was far less if they adopted this pool strategy from us. So they're now at 150,000. I look back at a deck I gave a couple of months ago, and it had said 130,000. And so they've grown significantly in that time, and they're still growing at about 3,000 to 5,000 databases a month. And it's just let that roll off the tongue, as it were. 150,000 databases. That's a significant portfolio. And they're split across 2 regions in Australia, and they literally stripe them across the 2 regions. They create a pool, fill that pool up, create another pool, fill that pool up, come back to the first region, and keep going like that. And so that's a very interesting. And the background of all this is there's not a DBA in sight. They're doing this with a DevOps mentality. They've built applications that, you think about it, you can't manage 150,000 databases easily by hand. You certainly would have an army of DBAs in a traditional kind of SQL Server installation with that number of databases. But they've automated the whole process. All of SQL Database's database management features are exposed through APIs and PowerShell commandlets. And they're all scriptable. And they've made extensive use of scripting and building applications that call against those APIs to manage their environment. OK, and in terms of performance, does it work for them? Well, this was taken just as we were migrating them last year. And so this is from our internal telemetry. This is the performance that we saw on those databases. And I show this because I have this slide. It's just the same now, with the following exception. There you can see it's 385 databases in a 200 DTU pool. Now they have 485 in a 200 DTU pool. So they've actually got more databases, and you can see there's plenty of headroom there to allow them to have more. So we increased the density at the end of 2016, allowing up to 500 databases per pool. And so you can see that this is the daily rhythm that I talked about. Here's, each day, customers log on, they connect, more of them are logging on and doing things in the middle of the day. The blue is CPU, green is log IO, and red is read IO there. So interestingly, those spikes in green, I happen to know, are individual customers, individual tenants who are doing that data sync process I talked about. So that's causing a hit against the database. And they had some interesting moments during tax season where they would get occasionally a couple of people would do that at the same time, and they would basically peak the pool, cause the pool to be 100% utilized. So we've been having discussions about how we can optimize, how they can optimize their process, and indeed, they can simply scale the pool up for the duration. But they look at the white space on there and say there's lots of capacity there that's not being used yet. So we like this story. So this is 500 tenants these days. It's up to about 35 to 40% utilization now in the midday, with 500 databases per tenant. Okay, so we took that learning from MYOB, the engagement with them, and many other customers that have been working with us, and we derived this set of patterns. And these patterns then are all about improving the design and management process. And everything I'm going to talk about now is domain neutral. That is, everything I'm going to describe could apply to any business domain. So we're going to take the database per tenant scenario, or model, rather. And what I'm going to do is build out a sort of mind map here of scenarios that pivot around this idea of a database per tenant, which together compose an end-to-end SaaS scenario. So if you're building a SaaS app, these are the kinds, you don't have to do all of this, you don't have to do it all at once, but these are the kinds of things that are going to come to bear. So let's just start the journey here. So first of all, I need to provision databases and schema. I mean, I need to actually create the database ready for the tenant's data to be put into it. These green annotations here represent technologies that can be brought to bear to actually do that, right? So then I need to know where, if I'm creating these 150,000 databases, I need to know which tenant is in which database. So I use the term a catalog, this idea of some store in which I'm mapping the tenants, again, some scheme by which I identify the tenant, identify the database that they're in. And we're going to use that to connect the app to the tenant. We're also probably going to use that, we're going to treat this database, this catalog, as a kind of, it's like a database for management. So there's a lot of interesting scenarios that literally look down on that database and allow you to manage it. For example, you can put additional metadata into there, so I can store additional information like SLA that I've given, or the service plan that I've given to a particular tenant, because that might influence things like the schema I'm going to deploy, or the performance objectives I want to have for that customer. So talking of performance, there's a whole set of performance-related scenarios. I want to monitor and alert on the performance. If I'm using these databases in a pool, I want to understand if a database has hit its max or if the pool is in danger of hitting its max. So I need to build an alerting kind of muscle there. I want to do this for the app and for the databases. So we can use the portal and OMS. OMS is a great story. So I can use OMS to monitor the database and the app, of course, so I can get a coherent monitoring experience from the PaaS platform on Azure. Then this idea of handling the fluctuations in the aggregate workload. So the workload peaks during the midday, or peaks Monday to Friday but is low on a weekend, then I want to be able to think about managing that. And I might react to changes in that workload. I see it spiking, so I do something about it. Or I'm proactive about it. I schedule to scale up a pool during a peak period. So that's being proactive, so I can go ahead and schedule these things as well. Then there's the idea of handling in a single tenant that has got a bursting workload. So take our ticket selling scenario. We've got a particular venue that's got a hot concert coming up, and they want to have a huge amount, they want to have a significant throughput for ticket sales for a small number of hours till they sell out that ticket. So they could actually, they might call me and say, hey, how about increasing the throughput for me? So I can avoid the noisy neighbor syndrome by treating them separately. I can, for example, take that tenant out of a pool, give them individual resources for a period of time. And I might do that in either of those modes, reactively, proactively, scheduled. Interestingly, I might offer that as a self-service aspect of the application. I might actually let the tenant do this. So actually, think about it. Let the tenant say, I want to have higher throughput for a period of time. If you match that to an SLA, like, for example, a number of tickets sold per hour as an SLA that you offer that tenant, you could easily see them invoking or requesting a higher SLA for a period, and that turning in under the hood for you using the APIs to call in and move the database out of the pool, give it a standalone set of resources for a period of time, and then putting it back again afterwards. I'm looking at the wrong picture here. So there's also the notion of geo-distributed databases. When we take databases, actually, what I think I missed out was load balancing back down here, didn't I? Yeah, so load balancing. So load balancing databases between pools. So if I have a hot pool and a kind of cool pool, one of the things I'm going to want to do is think about moving tenants between databases. Geo-distributed databases, that's interesting. When I want customers, I want to think about placing the customers in pools that are close to their location so they can log on. I always want to keep the app that they're using and the database co-located so I have minimum latency, but I can distribute those around the globe. Then if I'm building, and I gave the example of MYOB, provisioning databases in an automated fashion, one of the interesting things if you do that, so not just provisioning databases, but as you hit the 500 database limit, you're going to provision another pool. As you hit your chosen limit for the number of databases in a region or in a server, you're going to provision another server. So you want to make that an automated process. So think of that as one of the patterns. And then there's the idea of pre-provisioning databases. If you buy a pool, you're actually buying and reserving a set of resources, whether you use it or not. So in this scenario, you can provision a database. In this pattern, you provision a database before you onboard the client. So basically, you have a buffer set of databases ready to go with a schema all deployed on them, and then you're allocating a tenant to a database rather than provisioning a database for that tenant. So that's an interesting pattern to use there. And several customers are looking at that. That cuts down the onboarding time. I can, I don't have to, if it was standalone databases, I'd be paying for the database individually, so I wouldn't want to do that until I had, revenue coming in to balance that. Whereas with the pool, it's a different story. Then managing schema change, and we have a technology, and I'll talk about that more, Elastic Jobs for running schema updates across large numbers of databases. We might put schema version information into the catalog. That might be part of what it is, and actually drive the job submission process, the creation of jobs, based on this idea of determining which schema version should apply to which tenant, or should be rolled out to which set of tenants. Then there's a whole bunch of business continuity patterns and experiences here. So the idea of recovering a single tenant's data, and again, we've talked about that. So I can recover a single tenant with a database per tenant by recovering the single database. Of course, if I do that, I now need to update the catalog to say where that database is, because we always recover to a new database. PITR is point-in-time restore. So you have 35 of backups down to the millisecond. You can actually restore to a particular point in the transaction history with that. And this is another example where tenant self-service is interesting. So we have examples here where we can restore the database in parallel as well. So you can actually restore a database and then allow the app to connect to that from last week. So perhaps for compliance or other reasons, a tenant wants to look back at how their data was. So you might give them read access read-only access to historical data by restoring that. MYOB is very interested in this, in actually making this part of making this available to customers as a self-service option. You know, they get phone calls, you know, customers begging them to restore a database, and you know, they've screwed something up and they want to recover back to an earlier point. And it's an overhead for them to actually service that request. They completely believe they can make that something a customer can organize for themselves. Then there's the whole issue of managing at scale. We have a story, a built-in story for restoring from geo-redundant backups, so there's no charge for these backups. So there's, you know, what's interesting here, of course, is doing this at scale. I'm going to restore a large number, you know, tens of thousands of databases. How do I manage that process? What's interesting here with pools is one of the things you want to do is, because when you restore from backups, there's no guarantee of capacity. You know, you need to buy capacity and reserve it. But what you want to do when you're restoring large numbers of databases is think about restoring the pools first, because they actually reserve the capacity, and then later putting the databases into the pool. So a kind of a land grab, if you will, to grab the capacity for the pools, and then restoring databases progressively into that. And you might want to think about restoring them in sequence. You know, you want your most important customers brought back online first. So, you know, how are you going to do that? How are you going to think about prioritizing that? Then there's a geo-replication story, so it's a better recovery story, although this is effectively reserving capacity all the time by replicating databases, so you're paying for those extra databases. But in this mechanism, you're geo-replicating to another region, and you know, you can now recover much more quickly with much less potential data loss, so it's a higher quality recovery solution, but at a higher cost. There's some interesting cross-replication opportunities. You can replicate across regions, one region, each region replicating into the other one, so that if you actually have an outage, were to experience an outage, you've effectively got only half of your tenants exposed to that. So that's interesting. Cross-tenant analytics, so an amazing opportunity with a SaaS application is all this tenant data. So how do I get access to that? So if I've distributed it across different databases, how am I going to do that? So there's a story, and I'll show you this later. Querying across tenant databases is one scenario, and extracting data from these tenant databases into a analytics store of some kind, whether it's SQL database using column store indexes maybe, or SQL DB, SQL Data Warehouse, or some other store. You can move data out of your tenants for analysis purposes. There's search opportunities, and we demonstrated some scenarios around that using Azure Search, both doing search across tenants and search within tenants. And then there's a whole authentication and access control piece there. So the sort of puzzle completed there. But what's interesting then, so these are a set of scenarios, and what we've done is started to chip away at this, building examples of many of these, and I'll show you some in a moment. So actually writing scripts that do these things. But what was interesting, when I first wrote this slide, I put the pools word in many of these slides, doing this to a pool. But what I realized I could do is actually describe these in technology sort of independent terms, just as pure scenario statements. And by doing that, it was very easy to see that if we switched the guy in the middle to a multi-tenant database, that they all still apply. Every one of these scenarios here, every one of these patterns, they're typically going to be implemented differently because they're being implemented against this multi-tenant story or a hybrid multi-tenant story. So for example, auto-provisioning isn't going to be about provisioning databases in advance necessarily, unless because it's less important, except when I'm provisioning single tenants. So if I want to have a few pools used for those single tenants, then I might reserve capacity and provision databases for those. But I wouldn't do it for the isolated, the standalone multi-tenant databases. I would tend to provision those as I need them, or just before I need them. So, go back there. I meant to just light up all those. So you could see, and if you stop and think about every one of those, you can see how, let's take recovering tenant data after tenant error. So I sort of implied that was really difficult to do in a multi-tenant database earlier. But actually, it's not so hard to do. And with a catalog, it's actually quite easy to see how it works. You do the following. You recover the database. So now you've got a copy of a database, but the catalog isn't referencing that, so there's no one's using that data. The database exists. Now you come in and modify the one entry for the tenant you want to recover and say, actually, that tenant's data is in this recovered database. And then at your leisure, so now at that point, the app is fully able to talk to that one tenant's data, even though the database is full of maybe 100 other tenants. That data this is from last week, that data won't be touched by any of them, because each of those tenants' records, registration entries in the catalog are all pointing to the current copy of the database, the non-restored one. And then you simply come in and do the right thing now. You're going to clear out all the old tenant data for the other tenants, and you'll pull out the single tenant from the first database where he was active previously, and you might actually move the tenant back into there and delete that database. But you could do all of that behind the scenes. The recovery actually isn't so much harder to do. I mean, what's going to take longer is you've got a bigger database with a lot of tenants in it, so that recovery process would take longer. But the actual process beyond that is not so hard. And again, I class that as a pattern. There's a pattern of behavior there which can be used. It's got nothing to do with whether it's a tenant application or a ticketing application or a financial application, but you can use that same approach. Okay, so from this, what we get is what I think of as canonical, and by this canonical I mean sort of slightly simplified, idealized, perhaps, but this is, this is what we're seeing, a canonical database per tenant SaaS app, a sort of description of that. So it's a set of tenants connected to by the application. Some of these, and I would say canonically, they're probably in database pools, elastic pools, for load balancing purposes. The schema of these databases is the same in every one. There's no sharding. So though these are sharded, you can think of this as, logically, I've got sharding by tenant going on here, but because I'm committing to this idea of one database per tenant, there's no need to think about sharding keys and distributing data. Each database is one tenant's data. And then we have our catalog, which maps the tenants to the databases. And then we have the equivalent for a multi-tenant SaaS app. So it's the app now connecting to either single tenant databases or to multi-tenant databases. And again, the catalog. And what's cool about the catalog is it's exactly the same. There's nothing about the catalog that's different. And the schema here is, so databases now host single or multiple tenants, and the schema is the same for all of those again. It's just that the number of tenants contained in a database is going to vary. And now, of course, we are using kind of conventional sharding sort of think. We've got a sharding key that's probably the tenant ID of some kind that's included in the primary key of every one of the sharded tables in that database schema. Obviously, there could be non-sharded tables, reference data would be common across them, which would not have a tenant ID in it, and that would be shared. And that would exist once per database, whether it's a multi-tenant database or a single-tenant database. So let's come back to our app, the sample app. So the sample app is it's an Azure web app. You've seen the app. It's actually written with ASP.NET Core and Entity Framework. Right now, we don't have a core version of one of the libraries, so it's a .NET application at the moment. But we hope to make this available as a multi-platform app on the core technology shortly. So it deploys to Azure in less than 5 minutes, so you can try it out. It's super easy just to go and deploy it. I'll show you how to do it in a second. It's a database per tenant right now with the multi-tenant one coming soon, scripts in PowerShell, and I'll give you these. Obviously these links are sitting in the deck here, which you can download, and there's a resources slide at the end. It'll kind of come back to that. In terms of what we've done, we've implemented these scenarios as samples. So you can go and try out doing this. And here's the way to think about this. We've got lots of these individual technologies that we've built out over the time around SQL Database. And we tell people how they can use them to construct a SaaS application. But it's just so much nicer to see it done, see all of them put together and see how it actually comes together. So this is a sample. It's not a product. There's no way you should ship this. Please don't think you should go into the ticketing business, although some people have suggested they could. There are lots of edge cases that are not coded for. It's not a full-bore app. That's not the intent. It's all about showing you these patterns in the database. So please forgive us where we perhaps are a little weak in some of our coding standards in places, but it is pretty good. I just want to make sure you don't think you can go out and copy this and ship it as a production application. Please don't do that. So there's a lot of interesting stuff. I'm not going to read through them. I've touched on all of them. What I've tried to do is make sure we've got samples from pretty much all of those, that set of scenarios in that slide we saw earlier. So let's go and take a look at it. I need to log on again. So what I want to do is bring up another browser. And in this one, I'd point you also to a blog post that I wrote earlier in the year. So you can go find this guy as a link to this later on. This basically tells the story, puts in words much of what I've been saying today. Also, pretty much this deck is inside the GitHub as well, plus a demo script that's very like what I've been using. Behind this, there are then as a set of tutorials. So these tutorials are all online, and you take a look on the menu on the left here. You can see, let me just zoom in on this a bit. You can see where it sits, SQL DB documentation, how-to guides, multi-tenant SaaS, and then all of these here are the tutorials. This first one is a sort of getting started. And it contains, here's the list of tutorials. So each one of these, if you link off to these, this is the first one of them, gives you a sort of step through the sample, how to deploy the sample, this one, but then how to go through and run those individual scenarios, how to try out these. And a lot of it's done in PowerShell scripts. And so what I would strongly advise you doing is not just running them, because sometimes, it's sort of like so I run this script that does a deployment. Oh, look, it's deployed 17 tenants, sort of whoopee-doo. What did I learn there? Well, the answer is you should step through the PowerShell script. Go into the debug mode and step through it and see how we do it and see the techniques we use and see the way we use the sharding library to do the various things. That's what we'd love you to do. So in this one here, it takes you through. There's a deployment link here, and I'll click on that in just a moment. Goes through and basically takes you through the app. It walks you through what you can do. It talks about, for example, how to generate load on the databases and then how to provision new databases and so on. So this intro is like a high-level walkthrough, and then there are drill downs into specific topics that follow that. It's sitting on GitHub. So here we go, Microsoft Wingtip SaaS. The documentation folder here, I'll just pull that one open for a second. This has got an overview PowerPoint that's very much like this deck, which you can use internally to, sort of like sell this idea, sell these notions to yourself, as well as to your colleagues, plus a demo script, which is some of what I'm doing and a lot more besides. In a sense, all of the tutorials are like demos. They are going to go and take you through. But the demo script is, if you particularly wanted to actually show someone, that's a pretty good script to use to try it out. Go back to the root here, and again, there's a deployment button. And what I'm going to do is I'm going to go ahead and kick off a deployment here, just to show you how that works. So it's a template-based deployment, so it's going to use an ARM template, and it's going to deploy the complete app, so web databases and the works. You have to fill in just two things. You need to give it a resource group name, and I use a pattern to help me track what I've done, and a username. And the username is important because the username, and it's not a username, it's a user value. It's just a suffix that we're going to use on various resources. So when we create a server, obviously we generate the same app for everybody, but you can't have the same server name. You know, a server is globally unique, and app name is globally unique. So this is a suffix that's going to be appended so that you will get your own version of this. So you want to use something like your initials and a number or something. So I might use BGX as that value, and then what I do is I tap that guy into here. So wingtip BGX, you have to say, yep, I agree to the terms and conditions, and you have to say, and you click the purchase button, and that's kind of important point to mention is that you're going to pay for this. You're going to deploy this into your subscription, so it's going to cost you. If you do this, it's super easy to set up. It's going to deploy in less than 5 minutes. We won't stay and watch it. But it deletes even more quickly. You can delete it by deleting the one resource group. All right, that deletes the whole thing. So if you delete the resource group, you'll not be paying for anything anymore. And it costs, I'm guessing, less than $1 for a couple of hours use. So bear that in mind if you're using a MSDN subscription. And if you go crazy inside the app doing some of the scaling examples and you scale a database to P15, it's going to cost $1. But I don't recommend you do that. If you stay reasonable and you just play around, and here's the thing, you want to install it, try it out, delete it. Install it again tomorrow, try out some different scenarios, delete it. Just use it, consume it as you will, as you need it. Don't leave it lying around, unless you don't mind paying for it. If you've got an MSDN account, of course, you're going to get a credit. You have a credit for the usage there. Okay, need to keep going. So that was what we looked at there. So it's going off, and it hasn't installed yet, but it's got a few more minutes to go there. All right, so what I'm going to do now is let's talk about some of these patterns. And what I want to do is just talk through some of what happens in these patterns. So this first one here, provisioning tenants and connecting at runtime. So I've talked a lot about this catalog. So how does this actually work? So here's what happens. So inside the app, you're going to build it with what we call the Elastic Database Client Library. And today it's released in .NET, but we have a Java version that's just on the edge of being available. So we'll have the same library available for Java apps, so you better build the same solution in Java. In fact, one of the things I'd love to get feedback on is your interest in the Java version, and us maybe delivering a complete Java version of the sample. So that might be something we would do. And maybe even building versions of this on different databases. Would it be interesting to see this on Postgres, for example? So that might be interesting. So how do I go about onboarding? So here's what happens. The venue signs up as a new tenant. So I'm going to play the sort of, we've built some of this stuff into our app. So this is what MYOB does, for example. They go to their app, and they sign up as a new tenant. The app provisions a new database with schema. So it can do it by copying. So you can submit an ARM template. In the sample, it uses copying. Or you could deploy a DAC pack to do that deployment. Either of those, or a backpack rather, could be used to provision the database. Provisions the database and then updates the catalog using that database client library. In fact, you set up a database to be that client, to be the catalog, and the first time you connect to it with the client library, it will put the schema it needs into that database. Okay, then the application comes back, comes down here. It's going to now form the key in some way. So you might, in the sample, you'll see we actually take the key out of a venue name string in the path of the URL of the app. And we actually, basically it's part of the URL. You might look up in some, like a customer database. There are various ways you might get that key value from your own system in your own context. But you'll use that key now to connect to the app. And you actually call open connection for key. And what you get back is a connection. And you can use that connection to connect to the database. The point about that is it's just the normal process, except instead of you hard coding a connection or getting it from config, you're getting it from the catalog. It's going to return you a normal SQL database connection, or in Java it returns you a database connection, and you'll use that to connect to the database. And then the next time in, it uses location information cached in the client library. Actually comes down to the database, and in the database itself, there's some more schema in there holding basically a local cache of tenant information. And it's just going to verify with that it's still the correct database to connect to. And if it's not the correct database, it'll come back and go back to the catalog. So that way we don't have all the application touching the tenant catalog the whole time. Not every app they're not all hammering that one database, which will become a bottleneck very quickly. And think about this as this is technology we make available in that client library, which you would otherwise have to go and build yourself. There'd be something you'd have to do. MYOB did build it themselves. They started this before this was available. Okay, so I'm going to take another look at a demo. Something quick here. What I want to do is we're going to go and take a look at so let's come over here. So this is an example of one of the PowerShell scripts. In fact, what I'm going to do is I'm going to go and open here. And this is the structure you'll find. Here's my GitHub directory, Wingtip SaaS, learning modules, and then underneath learning modules are a set of folders, each one of which basically groups together scripts that are related to one of the sort of areas, one of the sets of scenarios. So we've got business continuity, disaster recovery, common is a bunch of common stuff. We've got some interesting DevOps and support, analytics, and so on here. We're actually using the provisioning ones here, and I've actually got it open already, so demo, provision, and catalog here. And what we're going to do here is, and I'm just going to check I've got a debug trace set on. I have flag. So we're going to go ahead and provision another database here. So this is in the single tenant version of this. So we're going to create a new database. So I'm just going to hit F5. And actually, what I wanted to show you was each of these scripts, if it does more than one thing, has this little block here. And so basically, any parameters you need will be above that. And then you pick a scenario, you pick the scenario, hit F5, and you're going to run it. And what you want to do is to sit in beforehand to try this out. You want to use F9 to set so just select a line here. Let me show you. If you're not familiar with this, here's the line. And I can toggle breakpoint with F9 here. I'm going to remove that one. So I'm already sitting right at this point. F11, I can step down inside, and then F10, I can just step through. So this is just normal PowerShell stepping through a script here. So in this example, we're getting some config information. So this first line, the WTP user, let me just show you that one file here. So this one file, so basically, we need to know which server and database you actually use. These common scripts, yet you ended up having your own custom deployment of this application. So in this script here, you just modify this one place, and you tell us here, if you update these values here, so this is me updating this, and from then on, all the scripts are going to reference this guy, and they'll do the right thing for you. It's user config for the scripts that then follow. So we were down in here, and where did it go? I went F11, so I'm actually sitting over here now, stepping through this guy, and it validates the tenant's name, tests it's legal. We compute the tenant key. In this example, we use a hash algorithm. We hash this compacted tenant name, turn it into an integer, and use that as the key to look up in the database. And we go through here. We check if the key is already registered in the catalog. And then we go ahead and deploy a new database. So this is where you'll see underneath here, it goes off and uses an ARM template and does a copy behavior to actually copy the database to create a new database. And then when that's finished, which will take a few moments, I'm actually not going to sit and wait for it. It'll go through there, and then we'd come along, and this next line here, we'd pick up here to add the database to the catalog, and at that point, we'd be completed. Right, so there's an example of the provisioning and how to use the scripts there. So let's come back here. So the next one I want to show you was the scenarios around performance management. And we've sort of talked some of this here. So in this scenario here, a provisioning service is assumed to have created a pool. It's created its pre-provisioned databases in it, and then the tenant, as before, comes in and registers, and they are assigned or allocated a database at this point, and that information is updated into the catalog. As more tenants on board, we pre-provision the next pool and databases, we bring in more tenants, and we're filling up the pool. We might increase the pool in size to handle more databases, more tenants. We might move databases between pools for load balancing purposes, and we can take a database out of a pool. So that's an interesting scenario, and you can try all of these scenarios out with the app. Let me just show you, kind of just quickly dip into the app again. We go back to, let me bring up here. We go back to this one here. This is the scripts against the single tenant database, and I'm going to show you the load generator. So the load generator here, so this is a kind of cool thing we did. So there's a stored procedure written inside the database, the tenant database, whose sole purpose is to consume resources. And it consumes them in a measurable way, or at least a configurable way. So we can ping this stored procedure and say, hey, run 20 DTUs, run 50 DTUs, run 60 DTUs for 5 minutes. So we've built a load generator then, which can set off a bunch of PowerShell jobs, one per database, which each job will wake up for a moment and then call and ping that stored procedure, triggering a load on the database. So we can simulate. And what's interesting is we can simulate the unpredictability of a SaaS workload. And you can play with a load generator and change the parameters. And you can use it on your own databases too, because it's a completely domain neutral kind of way of working here. And it's fictitious, of course, completely fictitious. And when you see the load in a moment, you think nothing more than, well, that's what Bill decided to show today. But it is something that you can do to try out these techniques. You can use it to try out load balancing. You can use it to try out pulling a database out of a pool, and just get your head around what that would take and how you'd write a script to do that, or how you would manage the process of doing that. And that's why it's so interesting. So you can see these different scenarios here that set off a load. I've already set off a load using this. It takes a few minutes, because it's a randomized load, it takes a few minutes for it to sort of like settle down and you just see the pattern that's going to emerge, because there are minutes between bursts from these databases. Now, otherwise, you'd be crushing the database. So if we come back, and this is the thing I kind of gave you a sneak peek of earlier. We go and look, this is the version. So, that amazingly jumped quite by chance to the right place. So here we're looking at, so this is live. I'm looking at the pool that's holding the databases against which that load is running. So this is what's happening. We've got this a load that's typically around 30 DTUs, and it's randomized. We've got 20 databases doing their thing. And I said it's completely fictitious. And the load you're seeing is just illustrative of the display you would see and the way you can use this to monitor the performance of a pool. And beneath here, you also see the performance of the top 5 databases. And here you can begin to see how those databases are being, you pick one color there. You can see how that's the intensity and the interval and the duration of the load are all different in each of these cases. But you can play with that. But what's really interesting is to see, and this has only been possible in the last few days, added this to it, is to go and take a look at the same thing running now in the database. So the multi-tenant database. So if we were to put these two into a pool, then we'd be looking at the same experience, looking at the pool, monitoring how those individual tenant databases were running in a pool. But here's a multi-tenant database, and my load generator is kind of agnostic. It just puts load against a tenant. It doesn't mind whether the tenant is in a database, or it's in a pool, in a database in a pool by itself, or in a multi-tenant database. So here's the same class of load, and I did use the same sort of parameters here to set up the load generator against the single database. By virtue of hitting looking up in the catalog to find where each job looks up in the catalog, finds where this tenant is located, connects to that database, and pings it at the right moment. And so many of those jobs, they're nearly all pinging the same database now. So we see the aggregate load. It's the same aggregation process. And that tells me something that's interesting. It's basically, there's a laws of physics going on here, which is you've got a certain amount of workload from your tenants that has a certain number of queries that need to get run, a certain amount of CPU and I/O that's required to sustain those queries. And whether you put them in different databases in a pool or in the same database It's the same amount of work that has to be done. And fundamentally, it's the same. And you'll see these look very close. The graphs look a little different because the interval here is different. It's, the other interval is showing you 15-second data points. So it looks spikier. This is showing you 1-minute data points. And that's why this looks a little different. But and I can't say it's the same load because both of them are randomly generated. But they're very similar. The criteria used to load these two were the same. But that's a kind of cool illustration by itself. Okay, I'm beginning to run out of time here, so let's pop back. What I wanted to do was so actually we showed you the load generation and performance monitoring. Just want to talk to schema management at scale. So this is using Elastic Jobs. So this uses jobs to deploy schema change, or actually just deploy any kind of workload, any kind of SQL-based workload across a set of databases. So you can define a job, you can define a target group, and there's a new version of jobs that we'd encourage you to use, which is in private preview, which we're very much putting all our weight behind at the moment. And that uses dynamic resolution of groups. So you can say, I want this group to be based on these servers and these pools, and as you add databases into those servers or pools, it'll resolve those at the time the job is run. So as you modify and maintain your fleet of databases, you don't have to keep adapting the jobs to it. So that's important. The jobs run against those databases, and jobs can return data, and I'll talk about that in a second. So if you want to join the private preview of this, and we would be delighted, I would positively recommend you join this if you're thinking of using jobs, rather than using what is currently available in the public preview in Azure. So we're not evolving that. We've got a different version. And what's big about the different version is it's a service-hosted version of jobs. So the jobs infrastructure we're hosting, and we're not expecting you to stand up a service, which is what you had to do in the public preview version. So we'd recommend you try that. So please send us mail to this alias SaaS feedback. Cook your neck around there. Then distributed query is another interesting scenario. I touched on that earlier. And that uses another database, another sort of management database, which you stand up as a head database, in which you describe external tables which reference the schema of the distributed databases. And actually, it also references the locations from the catalog again. And with this, you query, and now you're querying, it's just a normal query against tables in that database, and that is a distributed plan is produced, and that is then sent out across the set of remote databases, and the data is returned. Now, this technology is actually very efficient in its own right. It's the technology that sits underneath SQL Data Warehouse for its distribution over its distributed data. It's a parallel data warehouse using 60 databases beneath it, and that uses the same technology as we're using here. Query times may be longer, latency may be longer, because if you have queries that return a large amount of data. You want to optimize queries to do work remotely and return small amounts of data to the head if you can. All right, another quick demo. And in this one, I'm going to switch to SSMS. And here, I'm going to show you. So on the left here, you can see in the Object Explorer, you can see the databases. So I'm using, the database per tenant version of the application here. I'm going to do this demo over. And we've added another database. So we've got, in the top here, we've got this ad hoc analytics database, which is the head database, as well as the database that we copy from, plus the catalog itself. And over here, I've got the schema definition of that. So I'm going to go through this super quickly. The two key points here are there is a external data source defined here, which is basically saying, well, where are these tables located? And it's of a kind which is, it's a sharp map manager kind. So it's using the sharp map technology that we use in our catalog. And we're defining, this is going to come from the catalog server, which is the same server that we're running on. So it's this guy here, and it's the tenant catalog database. So this is basically saying where to go find the list of databases. So that's what this is for. And then down here, we have external table definitions, which are basically, it's as if we're going to reconstruct a single database in the middle that looks like a logical combination of all the databases remotely. So we're just going to define, so it's got the venues table, it's got the venue events table. And these are, and what's interesting here is we've actually defined a set of views in the remote database that actually add the venue ID. So remember I said there was no sense in which we're sharding the data inside those databases. They were uniquely defined separate schemas. What I mean is each database isn't using sort of foreign keys based on the tenant ID internally. There's no need to hold a tenant ID in that database. So actually we added it and then projected up through a view. So we can, when we gather the data from all these different tenants together through the views, we can actually reason about one versus another because we do have an ID that's now interesting to us when we put the data together in one place. So that was an interesting thing that we did, and that's talked through in the tutorial. But the consequence of this is if I run this, and this is all connected here, I can now run, some super simple queries, select venue name from venues, and it's just run that query across all of the databases. It did that query to those databases. So I could go say, well, so what type of venues are those? So it tells me the venue type, and that information on the remote database. And there are lots of other examples here, some more interesting queries you can run. But this gives you the idea then of how you can use distributed query. All right, so back to the deck. That was distributed query. So the next one is sort of like a peer to that. It's like a foil to that. So that's the ad hoc analytics story. But another approach is to use extracted data. So I'm not going to demo this. I'm just going to talk to this. This uses jobs again in the scenario we worked through. Runs jobs. Jobs, as I said, can return data. So actually, we're building this out at the moment. We return data, and we put that data into this analytics store. And we've got examples where that store is SQL Database or a SQL Data Warehouse. And actually, we're now, at this moment, we're sort of like improving the sample, and we're going to show you how you can shred the data, run another job on that there to shred the data into a star schema, for example, for analytics queries, suited for analytics queries, and then drop down and use Power BI on that and get this sort of information. So this is, you can tell this is a shaped graph. This is ticket data generated into those tenant databases and then retrieved. But you can do a whole bunch of interesting kind of analytics queries. And of course, the value to you as an ISV is this ability to look across your portfolio now, your set of tenants, and to ask questions about the way they use your application, to ask questions about the behavior, who's consuming most resources from me, and to ask really interesting questions that you historically you wouldn't be able to get hold of very easily because these databases would be sitting out deployed on some customer's premises. But now with the data in a SaaS environment, you've got access to this amazing resource to basically mine. Okay, so that's sort of the set of things I wanted to talk about today. I think I'm just scratching, maybe I've dug a bit too deep in places on what's available in the sample and these tutorials. So I'd love you to go try these things out. I hope I've given you a taste for, and I've made some journey, some progress on my set of objectives there, that you feel that you are better equipped, I hope, to at least reason about the choices, about whether I use a database per tenant model or a multi-tenant model, database model, or maybe a hybrid of the two, giving you some indication of why you might pick one or the other. Hopefully now, and on the next slide, I'm going to show you the resource list. You know how to go and get the sample and explore these patterns for yourself. I would stress again, try them out. And when you try out the scripts, do use that debug option, F9, set a breakpoint, and then step through them and see how they work. And you'll step through and you'll see there's a lot of common code there. Just step through it once. See how we do that construction of the tenant key, for example. Because a lot of people ask about how would you use a text value as a key, and that's a good illustration of an approach to use, a pattern to use for that. And I hope I've made some progress as well, convincing you that that SQL Database is just an awesome platform, we believe, to build out SaaS applications as a data platform for SaaS applications. As I said, by far our largest customers, so we've got many now with tens of thousands of databases running on it. As we show this multi-tenant, hybrid multi-tenant story and sort of like make more emphasis of that, I think we're going to see people adopting that, which won't produce the same enormous numbers of databases, but it will produce a very flexible environment for customers. I think people will value that. And we have a lot of interest from people looking at that platform there. And sort of importantly, install the sample, try it out, send us feedback. Again, saasfeedback@microsoft.com is an alias that the whole team is working on. You can send any SaaS feedback there, but actually it's mostly the SQL and the data platform guys who are looking at that alias. So that's really the point of that alias. Also, we'd love you, if you have time, and again, the link is going to be, if you take a picture of that, if you have time, we would love you to fill out a survey for us. And so here's why. That your feedback and answers to this survey are going to influence what we do going forward. So I mentioned the different platforms. You know, should we build a Java version of the app? Should we do different things? How important is it for us to show you how to do authentication and put a security model in place inside this app would be an example. So we have committed to building this class of sample as we think it's very valuable. We've had good feedback, but we want to make sure we're directing it in the right way. So please let us know what you're doing there. The resources. So these are the things I've shown you, the blog post, the GitHub repo tutorials. So when you download this deck, you'll get these links there. And this slide has been added for me. Please evaluate this session. Would love to get your feedback on the session, what we talked about today, obviously your feedback on the content and the presentation. Really appreciate that. And I thank you for your time. I will be here. I'm happy to stay for any amount of time you want to ask any questions. But also, you can send questions through email. You saw my mail at the beginning, bill.gibson@microsoft.com. All that, I also connect to that SaaS feedback alias as well. I'm on that. So if you have any questions now, I'm happy to take them. Otherwise, I'm going to thank you.